I'm going to go through the analysis of this ARP cache poisoning lab next. And remember back to our discussion of ARP cache poisoning earlier. I'm not going to rehash the whole thing, but ARP cache poisoning was a technique we discussed when we talked about various methods that you can use to tap into the wire and capture packets. It's a very effective technique for doing that very thing, and that's because it allows us to redirect traffic through a specific host. So you see we have this illustrated on the diagram where we have a target computer talking to a router, and we use our sniffer to inject specific types of ARP packets into the network that trick the target computer and the router into thinking that the sniffer is representative of the communication partner. So the target computer thinks the sniffer is the router, and the router thinks the sniffer is the target computer, when in truth the sniffer is actually just routing those packets between those two devices. And this is made possible because ARP is an inherently insecure protocol. So it's a useful technique for, of course, for packet capture, but also a useful technique for a bad guy who happens to be on your network and wants to capture your data. And if a bad guy can see your packets, he can probably do some pretty nasty things, as we'll show when we talk about HTTP session hijacking a little bit later. So I want to go through the packet capture I provided for you, this ARP cache poisoning .pcapng file, and we'll go through that and kind of understand what's going on, and also do a couple quick Wireshark config changes that help us do that analysis a little bit better. All right, I've opened up the file arppoison.pcapng. We're ready to go with our analysis, but just before we do that, I want to make a quick change and add a couple of columns that I think are particularly useful, specifically because we're going to be dealing with MAC addresses, so I want to see those in the column view. So I'm going to add a field for source MAC, a field for dest MAC, and we'll go over here to the fields area and go ahead and type eth.source resolved and eth.source underscore resolved, and then we're going to go ahead and do eth.dest underscore resolved as well, and that will give us the resolved version of the address values. I'm going to go ahead and put those here. We'll go ahead and drag source up right after the source IP address and dest up right after the dest IP address here. Hit OK, and we'll get those values. Notice I did do the resolved values, so we actually get, instead of the first three groupings here, we actually get the OUI. So it'll tell us Dell, Cisco, etc., and that's going to be useful just during the context of this exercise. These are not columns I always have in, but when I'm doing something like this where I'm analyzing where I believe there might be ARP cache poisoning going on, it's certainly very helpful, and I think you'll see why here in just a second. Now that we have the MAC addresses visible with the IP addresses, I want you to pay attention to some of the relationships we have going on here. First of all, we have a source address for these requests of 172.16.0.107. That's our internal IP address here that's communicating out to the internet. And we see we're communicating with a couple of different internet IP addresses. So we have 12.153.20.41, which appears to be a DNS server. We also have 74.125.95.147, which appears to be a web server. We see HTTP communication occurring here. Now, of course, this is the IP-based communication, which is for outside the network. Now, that means we have a source MAC address that is consistently tied to our source IP address, this Dell device here. It's identified with the Dell OUI and then C056F0. And then for anything out on the internet, we have a single destination MAC that's tied to all of those addresses. And that's because to get out to the internet, we're going through an individual router. And it appears to be a Cisco router here, Cisco Inc. 310733. And notice that it's the same destination MAC address for both of these internet IP addresses. These non-RFC 1918 addresses are both going to show that, and that's what you would expect. Anything going out to the internet will have the MAC address of your router, because that's how routing works and how the interaction between those multiple layers, the data link and network layer, is going to work. So that's an important thing to note here, is that we really have two players from a hardware standpoint. We have a source device, which is this Dell device, and we have a destination device, which is this Cisco router that we're sending our data to get it out of the network. Now, we can go ahead and look through this packet capture a little bit. There are not a lot of packets here, and we see what appears to be normal communication for the most part. We see there's a DNS request for google.com. We see some subsequent HTTP communication that results in a few more DNS requests, a little bit more HTTP traffic, some data transferred, and then we get here. We get to packets 54, 55, and 56, and these are ARP packets. And there's a couple things here that are odd that I want to talk about. So why is this ARP traffic weird or maybe not consistent with normal ARP traffic? Well, first of all, we have ARP traffic occurring related to devices that are already actively communicating. And not to say that that can't happen in some circumstances, but it's a little weird here midstream. And we'll start with this first packet, packet 54, and we see a new player enter the game. Notice here that the source MAC address is now identified as a Hewlett-Packard device. And of course, we don't have an IP address listed here because this is just ARP communication and it's all being done at the MAC layer. So we have this Hewlett-Packard address identifying itself, Hewlett P underscore BF 91EE. So it's a device we've not seen communicating before, and it's sending an ARP request directly to the Dell device, which as we know is our client, our web client in this case, and that's our internal device, our internal 172.16.0.107 device. And it's sending it to it and says, who has 172.16.0.10 tell 172.16.0.1. So this is a little weird in that it's actually a unicast, right? It's from a single host to a single host, and normally an ARP request is a broadcast type address. Remember, we've seen that. It'll send it out to everyone on the network segment, and then only the person with that particular address would actually respond with that data. So that's odd, the fact that we have this new player in the game, and then we also have this this direct broadcast direct unicast as opposed to a broadcast for this ARP message. Now, if we expand the ARP portion of this, we can actually see something also a little weird. And notice here that it says the sender IP address is 172.16.0.1, when that is actually not the sender. 172.16.0.1 is not associated with this device, this Hewlett-Packard device. It's actually associated with the Cisco device we've been looking at, the router. That's the router for the network, whereas this HP device is not the router. So it's forging that information. And of course, you have to have that knowledge previously. You have to know that that association exists, either through previous packets or just knowing the network layout in this case, which we provided to you in the lab. So you know that this is not the MAC address associated with this particular router, and that certainly is cause for alarm that something weird might be happening. The response to this from the Dell device occurs in packet 55, and it's a pretty standard response. It's just saying, responding with the information that was requested, saying 172.16.0.107 is at this MAC address, and it's providing that back to, in this case, the Hewlett-Packard device that's entered this equation. Now, some interesting voodoo occurs here in packet 56, it looks like as well. So this is actually an ARP reply. Now, notice we had a request and a reply, and then we had another reply. We don't have a request. And remember, that's one of the issues with ARP is that it will accept unsolicited information as part of its normal function. So in this case, we have the Hewlett-Packard device sending an unrequested or unsolicited ARP reply to the Dell device in this case, and says 172.16.0.1 is at 0025B3 BF91 EE. And of course, this is not resolved, but you can see BF91EE. That is actually the Hewlett-Packard device's address. So it's basically saying where you thought your router was 172.16.0.1 is actually not that Cisco device. It's actually me, the Hewlett-Packard device. And if you want to communicate out to the internet through that router, you need to communicate with me. And that's where the problem really manifests here. And you can actually see that manifest directly in the communication that follows. Here in packet 57, we're back to normal HTTP communication. We have a GET request, but notice that it is going from our internal host 172.16.0.107, the Dell device, to the right IP address, 74.125.94.147, which is Google IP, but it is communicating through the Hewlett-Packard device in this case, as opposed to the Cisco device. And we can stack these up here pretty easily, right? We see here that the DNS queries that are above this are going from the Dell device to the Cisco device, but now the communication is going from the Dell device to the HP device, which means that the ARP cache poisoning attack has occurred and is in place and running, and whatever that HP device is now routing the traffic to that to the internet through itself and able to intercept that traffic and read it. And of course, if the attacker can read your traffic, that's a bad thing. So in this case, we know that 172.16.0.107, our Dell device, is our victim, and the Hewlett-Packard device here is actually our attacker. Now, you may be asking yourself, well, this is only one side of the communication, right? We see these spoofed ARP requests and responses going to the Dell device, but shouldn't we also see this to the Cisco device as well? Because communication, of course, goes two ways. And you're absolutely right. But there's a good reason why we don't see that in the traffic here, and that's because this capture was actually taken from the perspective of the client device of 172.16.0.107, the Dell device. If we took a capture from the Cisco device, we would see that side of the ARP spoofing going on too. Whoever's operating that Hewlett-Packard device, the attacker, they have to send out these specifically crafted packets both directions so that they to one end of the communication and other end of the communication, because they want to get data going both ways to effectively relay and allow that communication to continue in a way that can be properly intercepted. So that's why you don't see all of those packets that you might expect to see there. This graphic shows an overall depiction of the process we just looked at the packet level. It shows our router, in this case the Cisco device, the victim, the Dell device, and the attacker, which is the HP device. And you notice we don't see the attacker's IP address there because we don't actually know it. All the work that's done by the attacker is done via the data link layer and MAC addressing. That's all that we need, and that's all that's visible in the capture, at least I believe so. Now, what we saw overall was the attacker inserting itself into the communication by sending ARP requests. It sends one to the victim, posing as the router, and then also sending an unsolicited reply saying that 172.16.0.1, the IP address the victim needs to communicate out to the internet, saying that it actually lies at the MAC address of the attacker, and you see that depicted in the third packet there. So this is a little tricky to keep up with, just because MAC addresses are not super intuitive to parse as humans. But if you add those MAC columns into Wireshark, that's really helpful. And when all else fails, if you see that a device is communicating with a specific IP address that's tied to a specific MAC address, and then all of a sudden that MAC address changes for that IP address, that's a sign that there may have been some type of intentional manipulation of that traffic. Not always, but if it occurs very suddenly like that, and especially if it's between a single host and a router, so it really may represent someone trying to intercept outbound and inbound internet-based communications to that device, and that's how, in this case, the attacker inserted himself into this communication and was successful ARP spoofing and intercepting communication between the victim, the Dell device, and anything out on the internet through the router, which is the Cisco device.